Okay, guys, so this week we're going to be talking about Earth's structure and processes. Go ahead and take out your Cornell notebook, start a new page with this topic and these learning targets. Okay, so we're going to be talking about all these different layers of the Earth. We're going to talk about the crust, the mantle, and the core, and as well as the lithosphere and the asthenosphere, and the differences and similarities between any of these layers. So the basic structure of the Earth is we have our crust. That's the layer that we are on right now. It's thin, rocky outer layer of the Earth. Consists of oceanic and continental crust. Important note here is that continental crust is less dense than oceanic crust. That's going to become important when different plates collide. Oceanic crust is going to end up going on top of, or continental crust is going to end up going on top of oceanic crust. The mantle is separated between the upper mantle and the lower mantle. It accounts for the most volume and mass of the Earth, making up 82% of the Earth's volume. And notice that the density of the mantle is greater than the density of any part of the crust. And the core is split between the outer and the inner core. The outer core is a liquid layer. The inner core is a solid. And the core is made up of an iron-nickel alloy, and its density, you can see there, 13 grams per centimeter cubed. What that means is it's just very, very dense. You see this pattern of increasing density as we go deeper and deeper into the Earth. So we can also split up the layers of the Earth based on how they act, their physical properties. As we get farther into the Earth, you'll notice that temperature, pressure, and density all increase with depth. Now, temperature, as rock gets closer to its melting point, it's going to end up melting, being able to flow. However, if we increase pressure, it's going to restrict that flow. So even though we are increasing temperature as we get deeper into the Earth, the increase in pressure keeps it from getting too malleable. So it's not all liquid. The layers based on physical properties are going to include the lithosphere, the asthenosphere, outer core, and inner core. So the lithosphere is made up of the crust and part of the upper mantle, and it forms a cool, rigid shell. The asthenosphere is going to be a soft, weak layer. This is where convection is going to occur. Convection is a form of heat transfer that causes tectonic plate movement. That's going to be very important when it comes to how our continents came to be where they are at this point. The asthenosphere is made up part of the upper mantle, but also a lot of the lower mantle. The lower mantle is a liquid layer or liquid-esque layer. It's able to move, flow like a boiling pot of water. That hot rock at the bottom is going to flow upwards, and then the cool rock is going to flow downwards, creating this current within the Earth. So we can see here, this is the basic form for tectonic plate movement. In the lower mantle, we have this really hot rock. As it heats up, it's going to expand, and it's going to flow upwards towards the surface. This gray area is the lithosphere. That's the cool, rigid shell. So as the hot rock flows in this circular path, it's going to push the lithosphere, and at these different boundaries, plate boundaries, part of the plate is going to go down, and then the other part is going to go on top of that. So we have this recycling of rock as this lithosphere gets pushed downward towards into the asthenosphere. Okay, we're going to be coming back to this in just one moment.